I'm going to now work through a few predicting product problems on page 23 from the unit packet. So for this first problem, I think it always helps to predict what type of reaction we're working with. So the first problem looks like a double replacement reaction, and the reason for that is that we have a compound reacting with another compound, and it looks like we have a positive, negative in each of those that could switch places. So for this first compound, I think it would be helpful to decide what the charges are of these respective ions. So potassium likes to form plus ones, and OH is one of those polyatomic ions, and it likes to gain an electron to form a minus one. So we have a plus one and a minus one. Now let's look at the second compound and again predict the ions that are forming this ionic compound. So hydrogen is in the first column. It likes to form a plus one. And the polyatomic ion phosphate, PO4, gains 3 electrons to form a -3 ion. So again, in a double replacement reaction, let's make sure we put the positive from this compound with the negative from this compound. So I'm going to place the potassium with the phosphate, and I'm not going to carry over the subscripts initially. What we now need to do is balance the charges of these respective ions. Now potassium likes to lose 1 electron each. The phosphate ions like to gain 3. To balance out a plus 1 and a minus 3, we're going to need 3 potassium atoms in this molecule. So the only ionic compound that's going to exist between K and PO4 is K3PO4. Now what else am I going to get? Well, when you get an H going with an OH, you could write it as HOH, but if we inspect this a little closer, a little trick here is that HOH is really just H2O. And these are already balanced. Okay, now that we've predicted what the products are going to be, now we should go ahead and balance the coefficients to make sure that we have the same number of atoms on both the reactant and product side in this reaction. So I have 1 potassium on the left and 3 on the right. I'm going to go ahead and add a 3 here. I now have 3 plus 3 is 6 hydrogens on the left. I'm going to need 6 hydrogens on the right. I have 3 oxygens not part of the phosphate, 3 oxygens not part of the phosphate, and I have 1 PO4 on the left side, 1 PO4 on the right side. So now we're balanced. In problem number 2, it looks like I have a compound plus a compound again. Double replacement's probably our best guess. As with the first problem, I'm going to go ahead and determine the charges of the respective ions before I predict my products. So calcium likes to lose 2 electrons each, plus 2. Hydroxide again, minus 1. Hydrogen plus 1. Chlorine minus 1. Now let's put the positive from the first compound with a negative from the second. So the calcium will bond with the chlorine. Now again, I don't bring over my subscripts initially. Now although we have 1 calcium and 1 chlorine on the left, when calcium bonds with chlorine, we need 2 of the chlorine atoms, each losing an electron to the 1 calcium. So the only compound that's going to form between calcium and chlorine is CaCl2. Always balance the charges first. Okay, now what else do we get? We have an H going with the OH again. So although we could write HOH, it really just turns into H2O again. Now that we've predicted the products, now we can balance the coefficients. 1 calcium, 1 calcium. I'm going to hold off on the O's and H's for a second. 1 chlorine, 2 chlorines. We need to add a 2 here. We now have 2 plus 2, 4 hydrogens on the left side, 4 hydrogens on the right. And again, that last element that we need to balance, 2 oxygens, 2 oxygens, it usually already is worked out. Problem 3, another compound plus compound. It looks like this is yet another double replacement reaction. I'm going to again figure out the charges. Aluminum plus 3. Nitrate, look at the list of polyatomics. The nitrate molecule likes to gain 1 electron. H plus 1. Sulfate minus 2. Now let's go ahead and put the positive in this compound with a negative in this compound. So the aluminum will go with the sulfate. Now since the aluminums want to lose 3 electrons each and these sulfates want to gain 2 each, a 1-to-1 ratio here is not okay. We would need to switch these charges and we would have 2 aluminums bonding with 3 sulfates. Now we would have 6 electrons being lost, because 2 times 3, and 6 electrons being gained, because 3 times 2. This is the only way aluminum sulfate will exist. Okay, now let's look at our other compound. It looks like the H is going to go with the NO3. Now although the NO3 looks like it's first here, we've always put the positive ion first when we're dealing with ionic compounds. Let's not change that. H, NO3. Now here's a good example of when I say don't carry over the subscripts. Because H is a +1 and because nitrate is a -1, we don't need any other subscripts here. One H will balance out one nitrate. Okay, now we need to balance the equation. 1 aluminum, 2 aluminums. Let's go ahead and add a 2 here. I now have 2 times 3 is 6 nitrates on the left. I need 6 nitrates on the right. And I have 6 hydrogens here. 3 times 2 would be 6 hydrogens here. And again, that last substance, we have 3 sulfates on the left, 3 sulfates on the right. That one's already balanced for us. Problem 4. C something plus O2. This has got to be another combustion reaction. Now the products of combustion reactions, we don't need to worry about charges here. We're just going to go ahead and write CO2 and water. Now following that Cho method of balancing, let's try the carbon first. 5 carbons, 5 carbons, 8 hydrogens, 8 hydrogens. 5 times 2 is 10, plus another 4 would be 7, plus another 4 would be 14 oxygens on the right. 7 times 2 is 14 oxygens on the left. Now problem 5. This looks like another decomposition reaction, and although I would never give this on a test or quiz, I do want us to give logical predictions here. Now there's a lot of different things we could predict for problem 5. One of my strategies again, let's go ahead and look over some of the other example problems. On page 19, we see that KNO3 likes to decompose into KNO2 and O2. If we would just look through a page or two of our balancing practice, we see that it's right there. Once we have the products predicted, I think we can go ahead. We have 1K, 1K, 1N, 1N, 3 oxygens, 4 oxygens on the right. Again, I think when we have a substance that has an odd number on one side and an even on the other, found in 2 spots, get rid of the odd number. So let's add a 2 there. We now have 6 oxygens on the left. Let's add a 2 here. We now have 4, 5, 6 oxygens on the right. 2 Ks, 2 Ns, 2 Ks, 2 Ns, and this one's all balanced.